bigger than the size of your hole of your inner diamond, of your inner race. So it's like this, you can see your size of your shaft is somewhere around there. It's actually overlaps with the inner race. Means that there is going to be a very split. If you look at your housing, this is the diameter of your outer race. Your housing board would normally be around there. It's actually bigger than your outer race, so that you have a very split. Questions? Questions? So if you look at your catalog, you will find some of these terms. You may have a small d, which is your inner diameter of your bearing. Basically, this is your diameter of the inner race. You can have your big T, which is an outside diameter. You can have a B or T, which corresponds to this. Now, we also want you to calculate the bearing life. Okay, all bearings will have a finite life. Your shaft is designed to have an infinite life. Your gears also, as long as you are below the allowable torque range, so theory is infinite life. The bearings all have a finite life. So to calculate the bearing life, we need to calculate one term, which is called C, which is a basic dynamic load rating. If you go to the catalog SKF, you will find this one also for each bearing. So C represents the constant radial load, which a bearing can endure for 1 million revolutions without failure due to fatigue. There's also another term which is called the rated life. It's given by LA. LA represents the life number of revolutions that the bearings will achieve successfully. It's the rated load given by that percentage. So if you want 90% of the bearings achieve the life at the rated load, your LA is basically given by L10. So L10 represents 90% of the bearings that will be able to achieve. The equation to calculate the life is given by this. So L is basically your life, millions of revolutions. C is the dynamic load rating, which is given for each bearing. P is your load that you apply to the bearing. So this is something that you calculate from your gears. K is basically a constant. Most likely you use a ball bearing, so K will be a 3. And what we try to do is to calculate C, because you know P, assume L, your lifespan. You know K. What we try to do is to find C so that we can go to the catalog and find a bearing which has a higher value of C than the one that we want for our application. Something that is extra, if your bearing carries both radial and axial load, which case in your case not only, okay, then you need to modify your P, which is given by this equation. Again, this equation, if you go to catalogs, it also give it to you. Okay, so let's jump to this. So let's say you have a cylindrical roller operating on a load of 7.5 kilometers. You see your load is smaller. Let's say this is 7.5 kilometers. What you want is 8,760 hours and 1,000 RPM. So what load rating should be used for the selection? Basically, the question is asking what value of C should be used. Okay, so you use this equation. This equation I showed you just now. So C is equal to P multiplied in brackets L over 10 to the power of 6. 1 over P. So P is 7.5 kilometers, 7,500 here. L is your lifespan, okay, is 8,000 8,760. Times 1,000 RPM. If you look at the equation, they ask you for represents L, the lifetime represents the life number of revolutions or hours. So basically this is 8,760 hours times 1,000 RPM. Here is per minute, so per hour is going to be multiplied by 60. Divided by 10 to the power of 6. This is your constant and this is your value. So if you go to the catalog, then you have to find a bearing with the value of C is higher than this value. Later we'll see from the example of the catalog what this is. Okay, so basically what you have to do is to find this value. This value, you go to the catalog, you have to compare, you have a list of bearings, you have to find a bearing with the C value which is higher than this. Okay, let's look at another example. The catalog is the basic dynamic load rating for a ball bearing to be 3,800 newtons for a rated life of 1 million revolutions. So what is the expected lifespan is subjected to 50,000 newtons. Again, use the same equation. This equation, you can find L, put your E over there, put your 10 to the 6 over there, and this becomes 10 over 6 times C, which is that, 3,800, divided by your P, which is 15,000, and your K is the power of 3, so this is what you get in terms of the revolutions. You want it to be hours, if you know the speed of the rotation, which is 2,000, then you can also find the number of hours. So for your case, you have to find a lifespan of your bearings. You may assume that the speed of rotation is 2,000 RPM, and you can calculate the number of hours that bearing can use. Okay, is a constant. So you just assume the K of 3 is a load. So basically, you know this one is from your gears. When you find your P, force. Sorry. This is from your revolve diagram. Force. Find the forces and your supports. So this is what you get. C is a value that you need to calculate. C is also a value that you find. What it looks like on the rock. That is most likely what you will be doing. So you know, you have calculated a load. You have calculated a radial load. And you calculated your shaft diameter. You know the speed which is for you. whether it's the maximum anyway, the one that is connected to your motor. You assume a lifespan, or you may not have to assume a lifespan. Basically, you have to find appropriate bearing. Okay, you have to find appropriate bearing. So what you do, first you convert your lifespan to revolutions. You assume this is the value, you find your revolutions, number of revolutions. You find your load from the three-point diagram, which is that, E is that. So if you use a calculation, you will get the value of C. L is in terms of the millions of revolutions. Okay, if you assume it's 10,000 hours, basically each hour you have 1,500 revolutions times 60, because this is RPM. So 1,500 times 60 would be number of revolutions in 1 hour. If you want a lifespan of 10,000 hours, it will be 10,000 hours times the number of revolutions in 1 hour. So it's given by this 10,000 times 1,500 times 60. K is a given, okay, the constant here 3 is given. It's a ball bearing, then is the K is equal to 3. So what you have to do is basically calculate the number of revolutions, the total number of revolutions, and also the load. This load, like I said, you can calculate from the free body diagram of the shaft. You can find the forces, the supports, basically that is the force for your bearing. Okay, once you have the value of the C, what do? You go to your catalog. You suggest SKF, because SKF is probably the biggest company in bearings. You can also find other companies like NSK. And most likely your workshop will give you some bearings from some generic brands. But what you need to do here, okay, you go to your product table, look at this. Let's say you choose ball bearings, simple ball bearings. You can actually specify the diameter that you want, the shaft diameter, and it will give you this. So if let's say your diameter is 3 mm, okay, you can look at the list of the bearings. These are list of bearings. You can see here this column is your C, which is your dynamic load rating. You can see all the dimensions of this bearing as well. Okay, this is dimension of your basically this is your load rating. Let's say for this question, you're supposed to look for a bearing with a inner diameter of 30 mm. So you come here, small d is equal to 30 mm. Your C value has to be bigger than 27,000. So you go to your catalog, you have to go through this, you look at this, your C value, this is 4.5, it's not good enough, look at this is now 29.6, which is bigger than the 27,000. Okay, so to pick your bearings, this is the one that you want. because your C value here is these three, the last three, will be bigger than your C value. Any questions? Okay, last year because I did not assume this, I get very different values in the report. Okay, from your seniors, some of them have almost infinite life, some of them have very limited life. Now for your case, should we fix this number so that you can base your calculation on? Should we stick to this 10,000 hours? 10,000 hours is quite short for your application. Should we fix this number so that all of you have the same number to work on? Yes. Only 10,000 hours is quite short. 10,000 hours is how many? Yes. It's not many years. Let's say 3 years. 3 years equals 3 times 365.
Fix number like
Four.
Plus
That's the
number
value
like
for this.
10,000 hours.
26,000. 26280. Okay, so 3 years, 26280 hours. So this is the lifespan that we are looking for your project. I think this is still relatively low, but I think you should be able to achieve this. So we assume it's 3 years. The batteries can last for 3 years. Basically 24 hours a day. So we think this is the 12 hours that you try to achieve. If it turns out to be too high, then you let me know. But I think it should be reasonable.
So it lasts for 3 years.
The speed you should be aiming for is 2000 RPM because that's the specification. And only the bearings that are connected to your motor should be speeding at 2000 RPM because the other bearings, because of your gears, you actually reduce the speed. So only the bearings which are connected to your motor, those are the ones speeding at 2000 RPM. Okay, if you look at this catalog, you can see SKF has very different types of bearings. And that's because they have different ways of dealing with lubrication. So lubrication of your bearing is important. Okay, because your bearings, if it's exposed, some of the ball bearings that you see are exposed. So if you look at your bicycle, some of them are exposed. You can see that you have a lot of dirt on it. Okay, you have a lot of dirt on it. Some of the grease also you remove. So basically, because your gearbox, most likely nobody will want to maintain it, so you need to have lubrication there, and you can use oil lubrication, but this means that your gearbox will have to be filled with oil. So grease is normally the easiest one that has to use. If you look at SKF, there are different types of bearings depending on how they deal with the lubrication. The cheapest one, the simplest one, is just cover. Basically, you have a bearing. You just cover it with what is called a shield. So this is the cheapest one. You can see it doesn't really do very much in terms of the grease reduction. It doesn't do very much in terms of the exposure. So it does do something, but it's not necessarily excellent because what you're doing is basically just covering. Okay, you cover your exposed areas with a ring. You have other types of seals, and these are more expensive. Generally, for your application, you specify the ones with the shields that should be sufficient. Okay, just last note. If you look at SKF, they also have different ways of calculating your LM, depending on the different types of your bearings. Okay, you will see this is your general equation. You will see that there are also some factors that you need to include. And they will tell you what these factors are. So if you talk about reliability of 90%, A1 becomes just a factor of 1, so we don't have to worry about this. So if you talk about 90% reliability, which we are aiming for, then your A1 is 1, so you don't have to worry about A1. But there are some other modifications because the type of bearing that you choose may be some special type, special lubrication, for example. So they give you also another type of factor. So this one are some things that you just have to be aware of when you read off the catalog. How do you calculate this lifetime? So if not, if they don't tell you any of these factors, you just use the standard one. Otherwise, if they tell you some factors, then you should also try to use this. So SKF, for example, has different types of bearings, some standard, some of them they call Explorer with the standard ones. So they have different types of modification factors. Okay, so that's all for bearings. Any questions? I guess you haven't reached this stage yet. You should, so for today, I hope you can really work out your gears, gear and assembly, then do some sharp calculations. Okay?